So before I begin my talk, I want to preface the talk with different things. First, this is a talk that I've done before at JavaZone 2010 in Norway. So if you've been to JavaZone, it's the same exact talk, except maybe with a little bit more longer demo in the middle. Second, I like to have my talks a little bit entertaining, and so I'm going to be making bold statements and somewhat provocative statements, especially about other build systems, including Ant and Maven. I do use Ant and Maven all the time, and I have a lot to say about them, of course. If you're not familiar with Buildr, it's a build system, and if you're not familiar with build systems and don't understand why you need the build system, you need to get out of your IDE a little bit more, right? I'm also pleased to introduce you sort of our new tagline, which is build like you code. And if you've used any sort of build systems in the past, like Ant and Maven and Gradle and Make, and there's a whole bunch of them out there, it sort of feels like you're doing something different from your regular programming, right? You're now programming in this other language, or you're now programming in this other world that you need to learn, whether it's sort of XML programming, and it doesn't quite execute the same way as your regular programming language. So you sort of switch hats and work on the build system, and the build system is sort of very detached from your product. And I think that's sort of a symptom, a design fail of some build systems. It's nice to have something that's sort of separate and decoupled, but at the same time you don't want the activity of working on the build system to be completely different from what you're doing with the rest of your system, because very often the build is, and what you make out of the build is part of your product, right? It's sort of all cohesive, how you package it, how it's built, how you're sort of assembling the components together. Shouldn't really be sort of this different from the other parts of programming. So we sort of chose this tagline to sort of capture that feeling, the experience of I'm working on the build system, but I'm still developing. I'm still applying all the same concepts and approaches and techniques that I've learned programming, but now I'm just working on the build system. So that's sort of the idea. And just so you know, the talk has sort of I'm going to be talking a little bit about the history of the project and why we built yet another build system. And then I'll sort of jump in the middle into sort of a live coding demonstration of what it feels like to use Buildr, and then I'll come back and sort of talk about other things at the end. So that's sort of the outline of the talk. A little bit about me. My name is Alex Boisvert. I'm French Canadian. I have this funny accent that people can't quite pinpoint. Yeah, it sounds French, but it's not quite French. It is French, but it's a dialect of French that's especially on the spoken side very different sounding. I happen to live in San Francisco. I live right in the neighborhood of Seacliff, so right by on the other side of the Golden Gate Bridge, very close to sort of China Beach, if you know where that is. So I'm local. I work downtown here. I like to call myself a sort of language polyglot, which means I use different languages for different purposes and use sort of the best tool for the job. These are sort of the recent languages that I've been using professionally. I have a lot more languages under my belt. Some of them I never want to use again. I started my career doing mostly C and C++ development, doing embedded systems, especially in the telecom world, so TCP/IP stacks on PBX and things like that. So the language I use most right now at the office are Scala and Ruby, if you care to know. I'm a Buildr committer. I am not the founder of the project proper or the original author of the project, although the project was created at Intalio, a company that I worked for earlier in the past. I'll be talking a little bit about the reasons why we started this at Intalio, but I also happen to be the PMC chair, which is the project management committee chair of the project at Apache. We're a top-level project. Each top-level project needs to have some sort of administrative person who sort of oversees the, administrative pieces of the project. So it's not a glorious role. It doesn't give me much more power. It's just that I handle, things like, I push the paperwork when paperwork needs to be pushed, those kinds of things, or make sure that process is respected. I work for a company called Bizzo. They're in the online advertising space. We're very much sort of in the same field as Google, if you want. Like, when you think about where the money is on the internet, well, it's in advertising and ads and all these things. Bizzo has nothing to do with Buildr in itself. So I use Buildr a little bit at work, but they help me get my job done. And if I need to work on Buildr, then so be it. But they're not in the business of supporting, developing a build system. It's just a means to an end, sort of. I use Buildr on a daily basis, and I've made several contributions to the project since it started, mostly related to the Scala support and plugins and extensibility, which I'll talk a little bit about during the talk. So enough about me, and if you want to stop me at any time during the talk, feel free to do so if you have questions, or I'm a little bit unclear, or I make a broad statement that you disagree on, feel free to cough. I want this to be sort of an interactive presentation, or I don't want to leave anybody behind. And actually, our first tagline was the build system that didn't suck, because when we, I was never meant to be somebody working on the build system. I think it's just an accident of reality. I never saw myself, working on at that level. But really, we started the project because I was working on another Apache project called Apache ODE. And Apache ODE is sort of this big Java enterprise middleware. If you know J2EE, the enterprise Java stack, it's fairly big, lots of dependencies. It's in the enterprise integration space, and so there's lots and lots of protocols and standards and formats. And it's the kind of project where we sort of feed on many other libraries and combine them together and make this component talk to this other component, and there's a lot of plumbing in between. The product itself happens to be sort of a process management software, but the large majority of it is sort of integrating with different systems, which means that most of the code deals with those sort of integrations. So in that specific project, we had more than 15 modules. We supported 9 databases, which is a lot of databases. We had more than 120 dependencies, all of them open source. Since Apache only allows you to release open source software as part of your product. We had 3 distributions, so we had sort of a standalone distribution that ran straight on Tomcat, if you want, like a WAR file that you can just deploy, like a web application. We had a distribution that was meant to go into another product called Service Mix, Apache Service Mix, which is a JBI implementation, Java, well, I'm losing my acronyms, Java Business Integration, yes. Java Business Integration. So sort of a JBI is sort of an internal data bus inside the JVM where different components can connect. So that's a completely different packaging. It's a different sort of set of dependencies. And we also have a distribution which complies with the SCA standard, the Scalable Component Architecture, which is yet another integration standard, Java integration standard. And so supporting these distributions required a lot of code or work to package and distribute the software into different sort of environment. So very tooling heavy. Like we had things like SQL generations for the databases. We had schema generation for generating XML schemas. We had an annotation processor to sort of go and read annotations in the Java code and generate other classes. Sort of name it, we had it, right? All of these things that need to be integrated together. Our first shot at it was using Maven 2. It was in the early days of Maven 2, sort of Maven 2.0, 2.01, 2.01, 2.02, and so on. And the reason why we chose Maven 2 is because we had used Maven 1 before, and it worked pretty well. Maven 1 had this sort of language called Jelly that allowed you to do sort of scripting, and we had been able to customize Maven to do a lot of things that it wasn't necessarily designed for, but we were able to add on top of it. And that was pretty difficult with Maven 2, especially at the beginning, because it didn't have these sort of scripting languages around it. It was supposed to have them sometime, but it never had or early enough. And the main sort of integration point was you could call Ant targets, and so we ended up with a lot of XML. 5,000 lines of XML spread over 52 files. That's a lot of XML. And we were like, oh, this really has to be a better way of doing this, right? It just doesn't feel right. And to be fair, the challenge that we had were not just related to Maven, but how people use Maven, right? And so, if you're not familiar with Maven, Maven is a very declarative sort of build system where you sort of state what you want, and you don't really care much about the how. Maven sort of figures it out, and it has all these plugins that are supposed to do handle the how. But in the way that you declare things, when other people integrate your components, Maven goes and reads the description and integrates that. And so it uses the description of other projects to do a lot of things in your project. And so if other people declare things in their project that are not quite right, if they don't declare all the dependencies, or some of the dependencies are not declared correctly, or the versions are too strict, or they publish a description in the repository and it's not quite right, it's too late to change it. And so there's like all of these sort of social problems around Maven that are not due to Maven itself, but just the way people use Maven, right? And so we were sort of victims of this, especially because it was also a transition, right? It was early days of Maven, so not a lot of projects had used Maven, and we were all learning together at the same time, and it was chaotic, to say the least. So what we really wanted is something that didn't involve XML at all. We sort of grew allergic to XML. We're not the only ones, but we sort of had this allergic reaction to XML. Something that was a lot more flexible than Maven, that worked sort of on smaller projects and one-off projects, and we happen to have a lot of customizations. And every time, sort of if you're doing what Maven was built to do, it's great. You're on the path and you're like on the highway and you're flying at 100 miles an hour. If you sort of deviate from that, it becomes like the trenches, and your progress is very difficult, and building plugins was difficult, and there was little documentation, and you also used other plugins that were not very mature, and once again, I'm not going to get into the details, but it was painful, and so we wanted something that was sort of more flexible and easier to extend and customize. We wanted to have a build system where we could say, here's what I want to do, and if I want to apply it to different things, I can build an abstraction for it and apply this abstraction to different things. And so one of the things we had was, we wanted to build, let's say, generate SQL, right, SQL, for different databases, and there was a plugin to generate, SQL, out of, like a Hibernate, configuration or a JPA configuration. But it only supported one database. And so if you wanted to support multiple databases, you couldn't just do like, run this 10 times, right? Like a simple for loop around this thing and say, this is what I want to do 10 times. Like, here's the plugin, here's the 10 databases I support. And we can do that. And so we had to shell out to Ant and run different things and build different files. And so we were really missing sort of the basic, software engineering tools of, abstraction and, composing components together in the build system. The DRY acronym here is don't repeat yourself. So we ended up, repeating ourselves all the time with, in POMs or in Ant or so on, just because we didn't have these, call this function with these parameters, right? So in other words, we wanted like a real language. And so there was, Buildr, and it just happened that, as we implemented this, our build got a lot faster. And it wasn't a design goal, but it just turned out that, at the time, and I don't know if it's still true because we don't maintain the Maven build system anymore, but Maven did a lot of sort of external, calling of Java, the Java compiler and the unit tests and so on. And the bootstrapping of the JVM every time made it so that it had significant sort of fixed costs every time you did a task. And Buildr just kept one JVM. We did run the test outside of the VM or in different VM if you want, but most of the compile and sort of the decision logic was run inside the same VM. Before we had 52 files, 5,000 lines of code or XML, and after we had everything defined in one file and about 500 lines of code. So we're talking like an order of magnitude change or difference between the two files. How did we do this? So Buildr is built on another tool called Rake, and Rake is sort of the Ruby make. And so it's a tool that existed before. If you're familiar with Make, it's sort of the same philosophy. And Rake itself is built on top of Ruby. So there's sort of 3 layers in the stack here. So we have Ruby, which is a great scripting language that allows you to do file manipulation in one line of code. You don't have to open the file input stream and open the reader and open this and that to go and read a file or write a file. You can just do that in one line. You have Rake, which allows you to declare sort of tasks and file dependencies and wire these things together. And Buildr, which is just a layer on top, which allows you to also define tasks, but in a very sort of project-oriented way. So it sort of keeps the Maven style, declarative approach of having like projects and nested projects on top of Rake. So why did we choose Ruby? Again, just because it's a great scripting language. There's all kinds of nice features in Ruby that are convenient to have, especially when you're doing sort of custom work. You want to, iterate over something. You can just do, here's my array and, for each over this or each over that, and run loops. You can easily execute external programs. It doesn't require, lines and lines of code to go and execute like another Unix or Windows binary and run an external command. So very, very good scripting tool. Very good metaprogramming capabilities that are sort of very accessible for casual use or casual programmers, so you don't have to be sort of a rocket scientist to use the metaprogramming facilities. And more specifically, the metaprogramming facilities in Ruby allow you to build sort of domain-specific languages that look like they're sort of native to the language. And Ruby happens to be a very sort of JVM-friendly language. There's sort of 2 ways that we can run Buildr. One is as running as JRuby, so running completely on the JVM. Or we can use what's called RJB, the Ruby Java Bridge, which is sort of running Ruby on one side and running the JVM as a sidecar. And so Buildr starts in Ruby, and whenever we need to call Java code, it sort of executes the Java code in the JVM and then comes back into the Ruby world. And it happens to be a very good compromise because the build tool starts pretty quickly. It's faster than starting JRuby because the JVM has sort of a heavy startup cost. So both of them are good choices. You can have a full Java implementation or sort of mixed implementation. So I want to talk a little bit about Rake. And you can sort of think about Rake as Ant. It's sort of the same conceptual level in the stack. So what Rake allows you to do is, if you have an application that has like sort of three components, right? You have a module that's sort of, C here that depends on A and B. The way that you structure these as sort of build task is you define a set of dependencies, and you have your application here that depends on packaging the three components, package A and B and C, and C happens to require compilation, but it requires A and B to be compiled first. And so the same way that you define these dependencies in Ant, like targets and dependencies, that's what Rake allows you to do. And it works the same way as make and Ant in the sense that if these dependencies happen to be file, like if you have a file A that depends on B and C, if they happen to be filed, then it will check the timestamps of the files, and if they haven't changed, then the task can be sort of skipped. And so Rake has these sort of built-in constructs to do dependency checking, but also clever dependency checking, so things don't have to be rerun all the time, and you get sort of fast build, or you only need to rerun the tasks that need to be updated depending on the changes. And so if A changes, then A would be recompiled, but B wouldn't be recompiled. You would recompile C and then repackage. So you have sort of this transitive dependency or domino effect in the transitive dependencies. So this is sort of Rake code, and this happens to be Ruby, but it's the Rake DSL. And so in Rake you sort of define a task like task, then you give it a name, and then you give it a block and say, here's what you do to achieve this task. And same thing for compile B and C. And here we have a dependency, so C depends on A and B, so this is like an array of dependencies here. Here's what we do to compile C. Package depends on three other things, and the default task is to package everything up. So that's Rake code. And I'll just state in passing that learning Rake as a standalone tool is very convenient, especially if you have anything to do with sort of the cloud. There's lots and lots of tools that benefit from using Rake and for like automation and starting machines on the cloud and monitoring machines and updating them and restarting them and so on. So generally something good to add to your resume if you think of using sort of cloud technologies. Very convenient tool in your tool belt. And so if you were to run this Rake file with these tasks, and it would just say, I'm compiling A, then compiling B and C, and then packaging everything, right? So this same application with three modules, we can redefine it or explain it in Buildr as such here. So instead of having sort of individual tasks that need to be wired together, and you have sort of a graph approach to your task. Rake is nice, but as you add more tasks, it becomes sort of a spaghetti, right? Too many tasks that don't have like sort of implicit wiring. So it's nice to be able to wire things hierarchically, because the hierarchy represents a natural dependency. And so my application naturally depends on A, B, and C, so I can just put A, B, and C inside, and I have this sort of implicit, dependency on all these things. And in Buildr, you would define the sub-projects and say, I want to do A and package it as a jar. Buildr adopts a lot of the convention over configuration mentality, and so if you're following conventions, then you don't even have to say that you have to compile something, because it will detect that you have Java files there, and it will just go and compile them, right? And if you have dependencies between projects, you can say, I want to compile C and compile it with A and B, and then package the resulting application as a web application, for instance, package the WAR, and then the libs that I'm going to be packaging are projects A, B, and C. So all of the libraries that are defined in projects A, B, and C. So far, so good? Yeah. All right, so if you were to, run this with Buildr package, then it would just, go through all of the tasks that it internally created, compile everything, and then package everything, and then package the application, which is the WAR file, and run any integration tests if you have any. So that's sort of the basic Buildr usage. And we have a set of default tasks that are defined that are sort of the backbone of Buildr, which are should be very familiar to you if you've used Maven, and even if you haven't used Maven, because these are sort of archetypes of build systems. So by default, we build the software. So that's the default task here. We build, and to build, then we sort of copy over the resources and process the resources. Sometimes you have properties files and you want to process them, like change version numbers or add a timestamp in there. And then the compilation would follow, then run the test, and that's the equivalent of doing the build. If you want to install, then that would depend on packaging the software. And then if you want to release, then it would upload before releasing, and then tag your project and your source control system and so on. And there's other tasks that are sort of standalone where you can clean, run some integration tests, which you can sort of hook onto different places in your build. So it's a standard task, but you're responsible for hooking it into your project where you need it. And you can also uninstall components. If you've installed them into your local Maven repository, you can uninstall them as well. We support Maven artifacts and repositories. So it's pretty difficult these days to use dependencies that are not in Maven repositories. That's sort of the reference in the Java world of putting all the dependencies in repositories. So if you have, if you want to use repositories, you can just say repositories remote. And repository remote happens to be a Ruby array, and so these signs here, these two less equal sign, are just append this repository to the list of repositories. So this is all Ruby code. Log4j is an artifact. There's a shorthand to write the artifact, which is the group, the name of the artifact, the type of the artifact. It happens to be a jar file, and the version. Buildr is a DSL, so we have different instructions to put things in the manifest, controlling the compile options. If you want to target Java 1.5, the version, compile with log4j, and so on. So this is how you use sort of Maven repositories and Maven artifacts. And so the nice thing about all of this is that artifacts are tasks too. And so whenever you depend on an artifact, then the task of the artifact is a task that will go and download or find the artifact in which repository it is and go and download it. And so all of this sort of graph of task is completely ingrained into Buildr, and everything you're doing is sort of wiring tasks together. Even though it doesn't look like we're wiring tasks here. Buildr supports a lot of languages. This is just an example. If you wanted to bring in the Scala support, you would just type at the top of your build file, require builder/Scala. That's the location of the Scala plugin in the distribution. And this brings automatically all of the Scala support. So it will automatically detect Scala source, compile them, do incremental compilation. We support mixed Java and Scala compilation. It supports generating documentation and so on. So fairly standard sort of use of plugin. And the way you do that is just by using the require keyword, which is a standard Ruby keyword to require another piece of code, which happens to be a gem. Yeah, I have a small project that we'll sort of be building together. So I'm going to create a project, sfjog, and I'm going to cheat a little bit. I've prepared a little project where I have already a small piece of code here, sort of globe here, and we're going to copy it here. Well, right, we're getting there. All right, so I have a small project here. I'm following convention, so putting all the source file under source main Java. The tests are under source test Java. I have a couple of tests here. You can see that I have a failing test. I have 3 different Java files here, and I can invoke Buildr, and Buildr will detect that I don't have a project defined yet. So it will offer me if I want to create a project from directory structure. So I'll say yes, and then it creates a project and starts compiling, the project right away. Compilation fails because the project requires some dependencies which I haven't defined. So let me just open the build file that was created here. Is this big enough for everybody can see? Yeah? Okay, good. Okay, so this is a big basic Buildr file here. There's some comments. I have a basic version, the group, copyright. I'll just strip these out and just keep the necessary parts. So the version is required if I want to package anything, so I'll leave it there. The group, I'll just say this is our group is org sfjug. We don't need the copyright. Define globe defines my project, so I'll be adding some dependencies here, and I'm going to cheat and just go and refer to the build file here that I made, and I'm going to declare 2 things. First, I'm going to use an environment variable which is called whirlwind home, which is assumed to be defined in my environment, and I'm going to pick up artifacts directly from my file system. So directly from this directory, I'm going to pick up all the jars that are there. So just to show that you don't necessarily have to use Maven artifacts, you can use files that are directly on your file system. If you prefer that, you can have a lib directory and source all the files directly from there. The reason why I'm doing this here is because Whirlwind is a project that has native bindings. It has it uses OpenGL, and it has native bindings, and people don't typically put native code inside Maven repositories. It's sort of frowned upon just because it's binary stuff that's not running on the JVM, which is a safe environment, and so Whirlwind is not typically found in Maven repositories. Some jars are, but not the native bindings, and having one without the other is sort of pointless. So that's why I'm doing this here, and also as just illustrative purpose. So I've defined, Whirlwind, which happens to be now an array of all these jars that are there, and I'm going to say compile my project with Whirlwind. And just for the sake of it, I'm just going to put a print statement and print the content of this array just to show you. So I'm going to type, Buildr. By default, Buildr tries to, build, which means we're compiling the project. And building also implies testing. And so we have a visual test here. So this is the Whirlwind project at work. So Whirlwind is a NASA project. It uses OpenGL, and it has like different sort of maps of the globe, and you can do interesting things with it and put texture on them and sort of do different kinds of plotting on the map. So interesting project, and I have test cases that need to be visual because testing the software requires visual inspection to get is the cube rotating as we want and so on. So just an easy way to test visually. So we have a failing test here, and I don't quite like this, and I'm not ready to fix it. So I'm just going to exclude this test for the time being. So I'm just going to write test exclude, and we're going to exclude all of the tests that have failing in them. Right? And I'm just going to run again, and it's going to run the test again, show the globe. It's rotating nicely. I'm happy. Great. And so test rotation worked, the frame test worked, and now we excluded the failing test, so everything works, and we're happy with our build. So one of the problems with these kinds of tests is you don't want to be running these visual tests on your integration server, right? That's not a good idea. And so these are meant to be sort of run interactively, somebody watching them. So how would you exclude tests that are, if you're running on the build machine and not on your machine, right? Like just a common, how do you do that, right? Well, maybe, you could add a variable that says, oh, we're on the build machine, so don't do this if we're on the build machine, right? Well, you could do that, and, it works. It's a good solution, but really, there's a better way to detect whether on the build machine is to say, are we running headless, right? And it just happens that Unix knows if you're running headless or not. So there's a primitive in Ruby, which is called, is the standard out? So the output, is it a TTY? TTY is an interactive terminal. So are we running inside of a interactive terminal? If so, then we can run the test. If not, then we shouldn't run the test because nobody's looking at this, right? So it's just an example of how Ruby can help you easily exclude tests, and you don't have to resort to environment variables and so on. So in this case, I'm excluding the globe test. Anything that shows the globe, I don't want to show if we're not running on the interactive terminal. So I'll just show you that if I pipe the output of Builder into something else, we're not running in an interactive terminal, so the test won't be running. That's it. Right? Simple enough. So far, so good? Yeah? OK. So let me just show a few other. Right. So if I run Builder again, even if I'm not in the interactive mode, nothing happens, right? Because I've built a project, nothing has changed, so it runs pretty quickly. Nothing happens. If I go and touch one of the source files, so I make a change. Globe frame, right? If I run Builder again, then it will recompile, right? So standard build stuff, but just wanted to illustrate this. And since we've rebuilt and we've changed the source file, then we'll run the test again, right? So this is just the transitive, dependencies at work.
I think we excluded those tests, or did you take that out?
I excluded the failing test, yeah. And I excluded the globe test if we're running in non-interactive mode. Yeah. And so that's why they're still running, right? All right, and if I want to, we already have the package as a jar task. So if I wanted to package this as a jar, I just type build package, Builder package. And if I look in my tree, I now have somewhere a jar that's called, sfjug, globe, and it created a jar. And if I look into this jar, I'll see all my Java files, the class files, and so on. Right? Just, again, basic stuff. So let's add another project here. So demo. I'm going to add a Scala project in here. So I have different Scala files here. We want to add some annotations to the globe. We have a globe actor. So in Scala, actors are sort of a concurrency primitive that allow you to sort of send messages asynchronously, and the actor will handle the messages. In this case, we're using the actor to sort of rotate the cube to where we're putting the annotations. And we have a test suite to test that everything is working correctly. So I'm just going to launch Builder here. Nothing happens because I haven't defined this project. So I'm going to go back to the build file, and we're going to say define. And this new project is called annotation. And if I define this project, nothing happens because I haven't loaded the Scala plugin. So nothing, no known sort of source files are discovered. So I'm going to run and require the Scala plugin. And now if I run again, it's now compiling the Scala files, and I'm missing some dependencies. So I have like all of these compile errors. Something I forgot to show you is we were printing the array of the dependencies, the whirlwind dependencies. So I have whirlwind.jar. There's GlueGen here, and GOGL here, which is a Java binding for OpenGL. So all of these jars were picked up, from this directive here. Take from this directory, take all of the jars and sort of concatenate them together. So I'm just going to remove this printout here because I don't need it anymore. And go to the annotation project and say, well, so we're compiling this, and I'm going to compile with the globe project. So the globe is a dependency. And I'm also going to compile with all of the dependencies of the globe project. So all of the compile dependencies. And then this, so our Scala project depends on everything that was defined in globe.
It's not automatically transitive?
No, it's not automatically transitive. So right now you have to say I want to compile not only with the artifact that's generated from this project, but all of the dependencies of this project as well, so that it picks up like the whirlwind, right? I'll talk a little bit more about transitive. We have also transitive primitive, but I want to sort of go sort of with a basic approach here. Yeah. And if we go back to Builder and build this project. Oh, so since I changed the build file, I might have changed something in the build file that affects the first project. So it rebuilt the first project. It ran the same tests. And now it's building the second project and running the test in this project. And so this test here is just showing annotations on the globe, right? So we put one annotation, and if we put another annotation, the globe has to rotate and place the new annotation. So just again, a simple demo here. And all our tests ran. And so since I'm changing the build file all the time, I don't want to rerun everything all the time because the build file has changed. So I'm going to use an environment variable which is called ignore build file. Okay. And so it won't be considering the build file as one of the dependencies as I'm changing different things. And so we also want to package, oops, my indentation is, package this project as a jar file. And now I'm going to move to a third project, which I'm going to call feed, which is a Groovy project. And I'm going to copy the project here. If I look at the project, it's just two simple Groovy scripts that I can compile and run. And once again, this project will depend on everything that we've done before, so it will depend on the annotation project and all of the dependencies of the annotation project. So if I run Builder on this project, I haven't added the Groovy plugin, so there's nothing to do unless Builder knows how to compile this. So now we're compiling the Groovy project, which has another dependency, which is called HTTP Builder. And so I'm just going to go and cheat again and copy something from the build file I had prepared. So HTTP Builder is just one of the sort of core modules of Groovy, which allows you to do HTTP invocations, get the result. The dependency sits in Maven 2 repository, and that's the sort of the artifact ID. It's inside the Groovy modules. The name is HTTP Builder, and I was using version 0.50 RC2. I don't know if there's a newer version. And in this case, I not only want this dependency, but I also want the transitive dependency, so the transitive closure of all the dependencies that are referenced here. So I have the transitive method here that goes and reads the POM, so the project description, and grabs all the dependencies out of this. And just for fun, I'm going to put out or do a printout of this dependency. If I do builder clean, so you see there's a whole lot of transitive dependencies. So we're depending on commons logging and some JSON library and a lot of HTTP related libraries, HTTP core and HTTP client, and we now have a Groovy dependency as well from this. ASM, I don't know why they're using this in all of these libraries, but it doesn't matter. This is a demo. I just grab all the dependencies. I'm happy. I have lots and lots of dependencies. And if I try to build again, it compiles using the Groovy compiler, and I get a few errors because I haven't told the project that I want to compile with HTTP Buildr and all of its dependencies. Run again, and hopefully everything will build. Great, so we've built our project. It's ready to run. So how do we run the project? We could define a new task using just the standard, rake. Indentation on this is terrible. I'll define a run task, and to run the task, I can just say I want to use, the Java runtime, and I'm going to cheat. And so Java commands, Java is calling the Java command on the command line, passing it the mid here, and the class path I want to have when I'm running this command is the compile dependencies of the project. Not only the compile dependency of the project, but also the output of the project, so the output of the compilation, which happens to be in compile target. Okay, and since the run command, since I've defined the run command and I'm in the feed directory, if I type builder run, it will run my script, my Groovy script. And since I have more dependencies, it takes a longer time to start up. And hopefully we'll see something. Yes. Okay, so this script essentially is a mashup. So what it does is it connects to Twitter. It reads a bunch of tweets. I selected the WikiLeaks keyword, so it's giving me tweets of WikiLeaks. It also goes and gets the location of all the tweets. And from the location, so if somebody lives in San Francisco, it connects to the Yahoo geolocation API. And from San Francisco, it gets the longitude and latitude coordinates. And it takes a little bit of time because these APIs, I'm not a paying member, so it's a little slow. They throttle my request. But what we should see, hopefully, is our globe with some tweets about WikiLeaks that have been sort of grabbed from Twitter, extract a location, call Yahoo to get the geolocation. And so we have people in the US, and if we're lucky, we'll get somebody in Japan or elsewhere that's a little bit more exotic. Australia, and so on. So just a basic application, just to illustrate, building this sort of, composite application built with different languages, all, wired together with this simple DSL. That's Buildr. Somebody in the UK, and so on. We could, watch this all night. And I actually wanted to run it with so this is the code that does, all of this, calls the Twitter search API, gives, this is the query, so I'm querying for WikiLeaks. So I'm just going to try to query for San Francisco Java user group, see what we get. It extracts, the response as a JSON document, uses the HTTP builder to call the Twitter API for getting the user locations, and from the user location I call, the Yahoo geolocation API with my security key here, and so on and so forth. So now that I've changed it to sfjug, if I run, it should recompile. So it recompiles my Groovy code. And hopefully some of you have tweeted about sfjug and we'll see something interesting. Wow, this is really slow. Oh yeah, looks like we're getting some tweets. Very nice. Oh, we even have tweets about me bitching about Maven. That is awesome. That is awesome. No, this is exactly what I wanted. All right. I'm hoping that all of you have some location in your Twitter account, because if you don't have a location, I don't display them. So hopefully. Thank you, Mr. Sanchez. Your location is not current, but that's fine. Twitter has attached location to individual tweets as well, so I should really get the location of the tweets. I was lazy and just get the location from your profile. Yeah. Yeah. And Antoine, oh yeah, Antoine is right here. So again, just a simple application that I put together for JavaZone. So now we've sort of covered the basics of building the application, taking the components together. So maybe we want to get fancy and write like a little plugin, right? And so I want to do something that Buildr doesn't do out of the box. And so something that we often want to do is put some version information into the jar, so that you know when the jar was created, and I want to have, let's say, like the SVN version where it came from. Since I don't want to set up SVN, I have Git running. Well, I can run Git here, so I'm going to initialize my Git repository and add some files here. I'm just going to add my build file and commit my build file. Right. So we now have Git going. So just gonna cheat again, and so there's a git command, git log -1 -- pretty format, which gives you sort of the current version you're at in Git. So that's an easy way to get the current version. And so to build a plugin in Buildr, you just create what's called a Ruby module. You just give it a name, and you include a Buildr module, which is called extension. And so extension is sort of a mix-in, so it brings in some functionality from Buildr into your extension. So that's sort of like importing some code from Buildr into your plugin. When we execute, so when we initialize this module, it will run the command git log that I just ran and put it in an instance variable called version. And using the extension methods that are brought in by Buildr, one of them is called the after define hook. So it's a hook that's run anytime a project has been defined. It runs when the project is finished being defined. So it runs as the build file is loading. We define a project, and when 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 Ruby parses, this block here, it finds define, and when it reaches end, your hook is called. And so after define, what we want to do is look inside the project and look for all of the packages that are defined in the project. And we're just going to assume that they're all jar files right now. We're going to create a file called git version and write the version number that we extracted from git here. So just create this file into target, enhance the jar, so wire this new file that I created, wire it as a dependency to the jar so that before I create the jar, this file needs to exist, right? And so enhance is a rake method, and this rake method is just creates a dependency that says, this needs to happen before this other task. So my jar file, as you can see, is a task. So the jar file is, is a task that that waits for all of the classes to be compiled and then, zips them up inside of a jar file. And what we're going to do is include this new file inside the jar and put it under manifest. So very simple extension builder plugin here. So I'm going to put this file, whoops, in the current directory here. If I just do ls, right, I have my build file here and I have git version, which is a separate Ruby file. And in our build file, I'm just going to say require git version, which is my extension. Right. So now the plugin loads as the build file is loaded, and the way to sort of hook it into projects is to say, switch here. I'm getting lost into too many files open. So I'm going to add this extension to my globe project. I could do it globally, or I can do it for a specific project. In this case, I'll just do it for a simple project. So I'm going to extend this project with the git version plugin. So when the project is defined, the plugin will be called. The after define method that was defined here is going to be called. And so it's just going to wire things together so that the git version, first git is called, the version file is created and then included in the jar. And so if I go into the globe project and I run builder package, it didn't do anything because I told Builder to ignore changes to my build file. So I'm just going to tell it no longer ignore the changes to my build file. So now that it detected that my build file changes, it recompiles the project, runs the test, usual drill, and then it packaged my project. And if I look inside the jar, there is no git version. What did I do wrong? Extend git version. Yeah, let's see if the file has been created. No, the file hasn't been created. This is fine. What did I do wrong? Did I? Oh, yes. Okay. I didn't save my file. I edited the wrong file and saved the wrong file. Our test is running again. And let's see. So the git version file has been created. And if I look inside the jar file, we should have the git version file here. So again, just a simple extension. If I didn't want to run the test, I could just say test equal no, and that doesn't run the test. The test wouldn't run anyway because they've been run anyway. Or I can put this as an environment variable and say, test is no, so I no longer have to pass this on the command line. So rake takes any sort of arguments like this, like name equals value, and automatically binds this into as environment variables inside for use inside the build file. So it's easy to pass in parameters to task and have conditional expressions into your build file based on arguments that are either passed on the command line or found in environment variables and so on. Yeah, something we really wanted when we created Buildr was to reuse the infrastructure that was there. We didn't want to go and rewrite compilers and rewrite lots of plugins that already work. And so Buildr can reuse any Ant tasks that you have or Ant plugins that you have. And so normally when you use Ant, you define your custom task using this. So this is an example using XML-based, which is sort of an binding framework for binding between XML and Java beans. And so in Buildr, you can do something that's very similar. And the notation is ant.taskdef. And then you can pass in the same information as you would using the taskdef. So it's just the equivalent of a builder, if you want, that maps to Ant plugins. And in this case, it's a little longer because we're wrapping this inside of a method. And I believe we do some wiring here. So in XML, we pass in the compile dependencies and some of the project paths here. So this is sort of just an equivalent of how you would use an XML, actually an Ant task inside of your build file or as a plugin. So we can just wrap existing Ant tasks as plugins. And so Buildr, for many of our standard features, like running, JUnit or running, code coverage using Corbatura and so on, we didn't go and rewrite a new plugin. We just reused the Ant plugin and just wrap it so that it's wired correctly inside of Buildr. This is an example, like I was saying, one of our challenge with generating database SQL database file mappings and just creating a for loop around an Ant task. So we have an Ant task, which is the OpenJPA mapping tool. So there's already an Ant tool for OpenJPA. OpenJPA is just like an object relational mapping tool. And so we just want to generate SQL database schema for all of these databases, Derby, MySQL, Oracle, and so on. And for each of those, we want to run this mapping tool. Not only that, but every sort of artifact that are created by an Apache project need to have the Apache header on top of them. And so this task also adds this header, which is the license header here, and concatenates this header with the generated file. And that's like an example of a typical thing with like Maven. You're sort of pulling your hair out. Like, how am I going to tell Maven that I want to generate this mapping file, and then for each of these mapping files, I want to add like this little thing on top of the mapping file? It's sort of excruciating to do that. And you also want to have sort of a clever mapping so that if you change the mapping file or if you change the header file, you don't want to recompile everything. You don't want to recompile like the entire project. So you want to be able to have a clever wiring so that the dependencies are wired in such a way that if you only change this, then it will recompile or regenerate the minimum amount of things. So just an example here. Another example here is just sometimes the artifacts that you depend on are sort of distributions. They're not the artifact itself. The artifact is inside of the WAR file or inside of another jar. And so this is just an example where the artifact that we depend on is a WAR file, but our dependencies are inside this archive. And so wiring tasks such that we download the WAR file, which is an artifact, and then unzip it, and then compile with whatever libraries are in there, right? Of course, you could go and every time the WAR changes, you could go and publish the jars into your own private repository. But it's just easier to say here's what you do when you have this sort of composite distribution where you need to point to or extract things from it. because we run either in JRuby or we run with the Ruby Java bridge, it's also easy to call just any plain Java class. And so the way to call any plain Java class is to prefix them with the Java constant and then the fully qualified path to the class. We're doing .new, which is creating an instance of the class and just passing parameters and calling the process method. So JRuby and the Ruby Java bridge do that fairly easily. So the integration, it's pretty easy to call any existing Java code. So if you're porting a build system and that used to call Java code, or if you have Java code that you don't want to rewrite in Ruby, it's just very easy to call from Buildr. I also wanted to show our support for test inside the build. And so we integrate with a Ruby gem called RSpec. And so RSpec is like a specification-oriented testing framework where you can sort of declaratively write your test. And you can say, well, whenever I'm releasing, check that the package that I'm releasing has a manifest in it. Making sure that the license is inside the manifest, making sure that a specific class is inside of a jar. This happened a couple of times in the Apache OD project where we wrote the build file and it sort of worked one time, and we released and realized that we're like missing files out in the distribution because some reason. So it's pretty nice to have also test written as part of the build file. Just like you test your software, you should test your build. And that's just one way to do that. We've already covered the Git version extension. And so I showed you how you can apply to a specific project. So you can just extend Git version to the project. This is just regular Ruby. In Ruby, you can extend any class instance. And so these are regular Ruby keywords and features. You can also apply to all the project by mixing in your extension to the Builder project. And so all of the classes that are projects automatically inherit from the behavior. So again, just standard Ruby stuff. And yeah, there's a lot of stuff that I won't be covering now. We can ask questions, but the layouts that you've seen, source main Java, that's not hard-coded. So you can define your own layout if instead of using source main Java, you use source Java or just Java or nothing. You can define your own layouts. We also have a profiles feature, so your build can act differently whether you're doing sort of local or development testing or integration testing or production. So we have these sort of profiles that are provide groups of information or that are triggered depending on which environment you're running. We have code coverage, build notifications. I think you saw these little bubbles when my build finished. So that's the notification feature. There's lots and lots of plugins. We have more languages coming. So I showed you Java, Groovy, and Scala today. There's a closure plugin that already exists that we're integrating into the core now. And if I dare go to the website, there's more and more plugins. And all the plugins that exist out there that are sort of Ant plugins already work in Buildr. So the ecosystem is as big as these other the existing Java ecosystem. So I can go to builder.apache.org. This is our build site. If you go to the community wiki, well, there's a lot of plugins that are discussed in our own documentation. If you go to more stuff, there's a bunch of things here. And if you go on the community wiki, we have a page where people who build extensions can sort of register and add their extension there. So if we look at Builder plugins, there's different there's different plugins, and a lot of these plugins are just wrappers around Ant tasks that happen to just provide like a convenient interface. So they're just easier to reuse. Yeah, there's different things. So yeah, we have integration with Ivy. So if you're using Ivy and you want to use like the transitive dependency features of Ivy or repo, you can reuse that. What we're doing for the next version in version 1.5 is sort of putting Ivy into the core of Buildr for some of our dependency feature, and so Buildr will provide sort of an opinionated integration with Ivy, and the Ivy for R plugin will continue to provide Ivy as sort of a generic extension where you can just program it any way you want or however you're using it already. What's going to be inside Buildr is going to be a more tight integration that's going to be less configurable but nicer to use for most cases. Yeah, and if there's like sort of one takeaway from my presentation is, you know, if you're scratching your head every time you sort of go to your build system and you're like, you know, this is a different mentality. I'm now, you know, building my stuff and I'm not, you know, coding anymore. I'm building. Sort of reflect on that and ask yourself, that's really what you want, or would you rather, you know, use all of the techniques that you know and apply them to your build system, and that's more and more common now. That there's more and more build systems that exist today than when we started the Buildr project. You know, Gradle is a Groovy build system that actually looks more and more similar to Buildr every day, except that it's, you know, Groovy versus, you know, Ruby. They're ahead of us in some areas, and I think we're ahead of them in some other areas in terms of features. So you can look at, you know, the specific features if you're adopting one. I think Groovy will give you sort of that same experience of, you know, coding and not, you know, like a separate experience. Same thing for, there's another tool called SBT, the Simple Build Tool, which is written in Scala. So every language sort of gets its own, you know, build system. I'm a firm believer that the language used for the build system is like a main driver for, you know, the adoption of the build system. And so as people, I think, will slowly migrate away from Maven. Maven won't disappear, but I think the adoption curve is slowed, and, you know, people who use Maven will continue to use Maven, and there's no point in, you know, changing a build system just for the sake of changing a build system. If you have something that works for you, there's no point changing. But if the build system doesn't work for you, you know, consider something else, and there are good alternatives out there. Buildr is an open source project, and we get contributions, you know, almost every week, certainly every month, from different, you know, people who use Buildr. I'm one of the contributors, but there's 8 other contributors, committers, and a lot more people who contribute to the project. So if you want to adopt Buildr, if it doesn't, you know, fit your purposes, you can of course extend it, but you can also contribute to the core of Buildr and help us, you know, make it better. So that's the end of my talk. Yeah. So the question is, how much of a pain is it for, I guess, existing, you know, build engineers and release engineers and you know, test engineers and like other people, not only developers but other people, I guess, that are either using the build system or integrating it into sort of the IT landscape. I think that depends a lot on the IT environment. Buildr integrates very well with Hudson and all of the continuous integration build tools. It's just a command line, right? So if you install it on the machine, it's a question of installing Ruby and installing the Ruby gem. So doing like Ruby gem install Buildr. And if you're on, you know, one of the supported configurations, you know, Mac OS, you know, Linux, Windows, then it should just install easily, and then you can use it like that. I know Antoine here, was another Buildr committer, was thinking about doing a Hudson plugin for Buildr, so that it's sort of easier to, you could just, you know, use the mouse and say, you know, install, and it becomes part of the Hudson configuration. I think that's a great idea, and that it would, you know, ease, you know, part of the, you know, pain of integrating Buildr into the culture and environment of large, company. And then the rest, I think, is just how you do it, right? Introducing any kind of technology into an IT department. It's how you coax people into managing the change. You start with a small project, or you could do like a covert operation where it's just Java, so it's just JRuby, so it's just a JVM. It works differently into different organizations. I haven't been in an enterprisey company for a while, so I don't know, and I haven't had to do that. I know that at Bizzo, where I'm working now, they had a significant investment in Ant, and they don't see a need to change or move away from that, at least for the existing projects. And so I think the question is more relevant for new projects, and just like any technology adoption, you want to start small, reduce the risk, and that's proportional to usually the company size and how many people are involved, and whether you're sort of an isolated project or the cornerstone of the company's future. Yeah. Yes. So the question is, I talked about consuming artifacts, Maven artifacts from Maven repositories. Do we support publishing artifacts in repositories? We do. And part of the question was whether we generate POMs and so on. So right now our support for remote repositories is we can go and put things in there, both a jar and a POM, with the caveat that the POM doesn't embed a lot of information right now, just because the way we do dependencies is different from the way Maven does dependencies. And so right now we don't put dependencies in there by default. And then you can override the POM by yourself and declare, well, these are my test dependencies, and you can grab them from your test task. And so you can do that. There's been a recent contribution where some of it is done automatically for you. And so I've been reviewing that, and it's been on my desk for a little while. I just had a second child recently, so that's been taking my priority. But that should be in the next version. So minimal support for that. So you'll get sort of a default, should do the right thing for simple projects. And if you have more complex projects, you might have to do some manual mapping. And our hope is certainly to have, if you're using the Maven dependency system inside of your build file, and if you're already managing your dependencies in the same way that Maven does with, compile, runtime, provided, and so on, then you would get exactly sort of the same experience. Yeah. And because we'll get this from IV, which does the right thing for Maven. Yeah. So the question is, since we don't publish complete dependency information inside the POM, how do I what's the best practice for sharing artifacts between two teams or two external people? Well, I think one option is to just provide the information, which is a little bit more work, but you can provide the information in the POM and you get exactly what you want. As a personal preference and opinion, I think I'm considered a heretic in the transitive dependency world, but I have faced personally so many issues with transitive dependencies that I don't do transitive dependencies at all anymore, ever. Maybe I'll do it for when I'm starting a project and just like to get off the ground. But there's two sort of schools of thought here. There's which I usually label as whitelisting dependencies and blacklisting dependencies, right? So Maven is essentially a blacklisting model where you say, here's the dependency I want, and it will get the transitive dependency for you. And then you sort of manage things by exception. So you blacklist things. And so you say, well, I don't want this jar, or I don't want this version, or I want this version instead of this other version. So that's one school of thought. The other school is whitelisting, which is I'm going to tell you all the dependencies I want, and explicitly, there's no guesswork, because I give you a list and you take this list and run with it. And I personally found that this model works better on bigger projects, and it's a little bit more of a pain to do it for smaller projects, but I take the hit and adopt this, and so I haven't found transitive dependency and information in POM to be useful on large projects because there's so many exceptions that you end up doing a lot of work, a lot of sort of guesswork, over time. And so let me just finish the thought here. So I equate this a little bit to sort of the optical character recognition, right? OCR, right? OCR has been at a level where they have like 99% accuracy, right? They recognize, you know, you put a sheet of paper in and they recognize 99 characters out of 100. Well, equate this sort of optical recognition, right? Has been that they have 9% recognize sheet of paper in recognize 99 out of 100 I equate this to sort of optical recognition, right? Right? Has been that they have artifact 9% maximum C, right? Recognize do we publish a paper in recognize 9% is and part out of 100 is whether equate this optical recognition, right? And part has been that was whether they have 9% the recognize that the paper is recognize the recognize 9 out of 100 the out of 100 I said the equate this to sort of the way optical recognition, right? The way, right? The part has been that they have the way 9% sees right? The way recognize does the paper is recognize 9 out of 100. Well, equate this sort of optical recognition, right? Has been that they have 9% recognize the paper is recognize 9 out of 100 out of 100. I equate this to sort of optical recognition, right? Right? But has been that they have 9% C, right? But recognize the paper is recognize 9 out of 100. Well, equate this sort of optical recognition, right? Has been that they have 9% recognize the paper recognize 9 out of 100 out of 100. I equate this to sort of optical recognition, right? Right? Has been that I want. So the question is, when I say whitelisting, do I mean flattening all the dependencies and putting them on the same level and managing them this way? Not really. That's the simple case, and that's sort of what I've been showing in this talk. How it works practically is a little bit like what we used to do with Maven 1. And so when you start doing whitelisting, you start saying, well, here's a group of dependencies that we know work together well. And so for project something, here's the list of dependency. And so project something becomes like an array, right, or a map or something.
It's include instead of exclude.
Yes, it is include instead of exclude. But when you're doing these lists, you can package them into arrays, maps, different categories, however you want. And you can, because Ruby is very flexible, you can now share these lists. And so you can have multiple projects depending on the same lists. Okay? And so that's sort of an alternate system to POMs, where you're publishing these lists and lists of dependencies, although you're managing all of them explicitly. And so if you have multiple projects and inside one company, multiple, you're publishing artifacts and consuming them, you can share these lists the way that you do with POMs, except you're managing them versus somebody on the internet that decided that dependency X was dependent on log4j 1 to 14 and not 15. Okay, so I think 3 questions. So whether we support snapshots, yes. Whether we can enforce that we're always using the latest snapshots, and whether we can publish into snapshot repositories. So yes to all of the above. So we support consuming snapshots, and so we look again in this manifest file that contains all the snapshots, pick the last one. You can enable or disable the feature, and so that's an environment option. I don't remember exactly the name of it, but it's like, snapshots yes or false, true or false. And if it's true, then it will check for snapshots, and by default it's false. So by default it's false, and you have to specify it on the command line to say, I want to refresh the snapshots, and then it will take the last one. And whether we can publish snapshots in snapshot repositories, right now it's a manual operation, so you have to do a conditional, right? So the same way that you define remote repositories right now, you say, repositories remote equals blah. You would say if my version is this, is a snapshot, so you'd probably use a regular expression just to check if it's a snapshot. Then use this repository, otherwise use this repository. That's how we do it today. There is somebody working on sort of native support for snapshot repositories so that they're published automatically to snapshot repository. So right now we have sort of one repository, source of repositories, where it can be snapshot or both, and we're separating them to be sort of in line with the Maven conventions. For today, I would probably adopt something like Gradle or SBT in combination of IV, starting from a clean slate. I would not personally use Maven 3 myself, despite all the features that they've added, just because it's sort of fallen out of favor in my own set of preferences and opinions. And for that reason, I haven't kept up with all the new features that are in Maven 3. I know they've improved a lot of things, they've fixed a lot of things, but I haven't kept up. So I couldn't give you sort of a good and fair comparison, mostly because I don't have the accurate information now. And build systems are quite complex, and even if you ask me questions about Buildr, sometimes I don't know. I have to go and look at the source. But in terms of just philosophy, Buildr is such a small code base, and it's very flat. It doesn't take you a long time to understand exactly what's going on, whereas for me, Maven has evolved into a bigger and bigger and more complex software, sort of a bigger framework. And the way I explain this better is, it's the difference between a library and a framework, right? A library, you call it, right? You call the library and you say, do this and do that. A framework calls you, and so you're always sort of at the mercy of, what are the hooks that I can play with so that I'm called at the right time to do exactly what I want. And so for this reason, for me, it's sort of, not my first choice anymore. Yeah.
Thank you.